Hey True Class, this is our first notes since we've moved over to online format. So I am going to go with the PowerPoints from Hawks to kind of as our foundation. I kind of use these in class. I just have them kind of jotted down on a piece of scratch paper. But I'm going to use these as our foundation and post these for you, and then they'll have links to some of the Desmos things that I create. And I'll do this kind of a couple times a week to make sure that we're staying up with our notes in class. All right, so let's go into 8.2. We got plotting points with polar coordinates. So how does this work? Well, I'm going to put a big red dot where this first point is. So 2, 3 pi over 4 is our polar point. The way these work is this is R, all right, this is R, and this is theta. These are written in an ordered pair, just like x, y is an ordered pair when we're doing rectangular coordinates. But r is the radius, how far we are from the origin, and 3 pi over 4 is the angle. So if you look over here, my radius, this is 2, this is 4, so right there in the middle, that's 3. So 2.5, 3, 3.5, 4. So this is the 3 circle as I rotate around, and it's telling me to rotate to 3 pi over 4. So if you recall, the pi over 4s are the 45 degrees. So that's 1 pi over 4, 2 pi over 4, 3 pi over 4 would be right here. And on the 3 circle, that would land me right there. So there is the point A. I'll call it A and just write it like that. All right, now I'm going to switch to a different color to do B. I'll do it blue. And it's at 3.5 and negative 5 pi over 2. So there's 2, 3, 3.5. Now negative 5 pi over 2 means I'm rotating this way. Remember that. I rotate clockwise when I'm doing negative angles. 5 pi over 2, well remember that's 4 pi over 2 is 2 pi, and that would be all the way around. So 5 pi over 2 would be all the way around 4 pi over 2 plus another pi over 2, which would be down here. So 3.5 negative 5 pi over 2, there's 3.5, there's 5 pi over 2, so we would be right there, and that would be point B. Alright, and now as I mentioned in the other video, when we have, I'm going to do black, when we have a negative R, that's a little bit different than when we have these positive R's, where I just rotate by the angle and then put the dot that far away from the origin. So we're still going to rotate by this angle. So 4 pi over 3. If you look really closely, right there is 4 pi over 3. So technically we're on this line right here. So from here to here, that's the line I'm supposed to be on. That's the 4 pi over 3 line. But when r is negative, what you have to do is go back through the origin and you would be on that same, the absolute value of that same one. So the absolute value of negative 1 is positive 1. So there's a half, there's positive 1. Alright, so there's positive 1, 4 pi over 3. But when it's negative, we go back through the origin that same distance and put the point right there. So at this point would be at the same place that it looks the same as there's 1 and positive pi over 3. Okay, so it's basically like we rotate to this. So there's 4 pi over 3. There's where positive 1 will be, but because it's negative 1, we go back through the origin to that same distance on the other side. So that's point C. So it looks like nothing matches up. It looks like the angles don't match up, because it's pi over 3 when that says 4 pi over 3. But it's because the r's don't match up. We're on the one circle but that's what a negative r means. It means go back through the origin, go the opposite direction from where you are now. So if I'm right here, I go back the other way. So that's a very important thing to get used to when we are dealing with polar coordinates, is that r can be negative, and it just means go in the opposite direction back through the origin. Alright, and then this is what we talked about in that last video, how to convert between a polar coordinate to a rectangular coordinate. You just take your r, your theta, and you throw them into that formula. That'll give you your x and y coordinate. So even if r is negative, you know, depending on the cosine and sine, that'll change the signs and put us in the correct quadrants based on the sign of r and the signs of sine theta and cosine theta. And then this is what we used, and we talked about that in the last video as well, to go back and forth between rectangular. If I have a rectangular and I want to go to polar, I need r and I need theta. So these are direct. You plug in the polar coordinate into the r and the theta, and you just simplify those expressions, and there's your x and y. But these, the way that they're presented, the way I present them anyway, yeah, I could present this as r equals, you know, the square root of this, or theta equals arctangent of this. But remember what we said in the last video. It's best with these to have your unit circle out and just find the correct angle depending on what quadrant this point is in, because arctangent, remember, is only defined in quadrants 1 and 4. You can find the tangent equal to this number in any quadrant. And then I just present it in this manner just because it looks like the Pythagorean theorem, and I think people remember it better when they see it that way. All right, let's look at a couple of these examples. So convert this to a rectangular coordinate. So if you look here, r is 2, theta is negative pi over 3, so x equals r cosine theta. So cosine, that's the x coordinate, negative pi over 3. Let me pull this guy up right here. This is my unit circle. If I look at negative pi over 3, that's pi over 3, so negative pi over 3 would be if I rotated this way by that amount. So that would put me down here at 5 pi over 3. Okay, and cosine of theta is the x coordinate there, which is the half. All right, so 2 times a half is 1, is where that's coming from. Y equals r, 2 times the sine of that, and sine is negative square root of 3 over 2, and the 2 and the 2 from the negative square root of 3 over 2 would cancel, and it just leaves you with the negative square root of 3. So the point coordinate becomes 1 and the square root of 3. Or sorry, 1 and negative square root of 3. All right, b is negative 3 pi over 4. So again, pi over 4, if you look, sine and cosine are both square root of 2 over 2. All right, so r cosine theta is going to be negative 3 times square root of 2 over 2, which would be negative 3 square root of 2 over 2. And then the y coordinate would be the same thing, because sine and cosine are equal at pi over 4. So we'd get negative 3 square root of 2 over 2, negative 3 square root of 2 over 2, which is the same thing as we said in class. Square root of 2 over 2 is the same thing as 1 over the square root of 2. So they have it written that way. All right, so either way is fine, using the values from the unit circle, or not rationalizing the denominator, which is what that example showed. If you didn't rationalize the denominator, those would be 1 over the square root of 2. All right, convert from Cartesian or rectangular coordinates to polar coordinates. So these are x and y. So here we need the other two. So that's these guys down here. And so I need to get, this is x, this is y. So r squared is equal to negative 3 squared would be 9 squared. Oops, sorry, plus 2 squared, which is 4. So that would be 9 plus 4, which is 13. So r is the square root of 13. Okay, and then theta is given by this, tangent of theta is equal to y over, so 2 divided by -3. So tangent's equal to that, so theta would be equal to arctangent of that. Now here's the thing. This is a negative number, -2/3. Remember, the arctangent is only defined in quadrants 1 and quadrant 4. If it's down here in quadrant 4, it's so important that you understand this. If it's down here, then the angle is a negative angle. It's going to be this angle, a negative angle. Where are we? -3, +2. We're over here. We're in quadrant 2. Arctangent is not defined here. So what do we have to do? We have to find this angle, which is arctangent. And because we're in quadrant 2, we have to add pi to that. And that's how we would get to that value. Okay? That's not a special angle. So we're going to end up with a decimal answer, which I'll show you in just a second. All right, so there's r, and there is theta. All right, so for this other one, how do I do it here? This is going to be a special angle. To get r, I'm going to do the same thing. R squared is equal to the square root, or sorry, r squared is equal to x squared, which is 3, plus y squared, -1 squared is 1. R squared equals 4, so r is equal to the square root of 4. So r equals 2. And then the tangent of theta is equal to -1 over the square root of 3. All right, or you may know that as negative square root of 3 over 3. All right, same thing. What quadrant are we in? Once again, look here. What quadrant are we in? We're to the right, that's positive, or down, that's negative. We're in quadrant 4. All right, we're in quadrant 4. That's going to give me, arctangent would give me a negative angle. But I can use my unit circle. I can go, like I did here, I can go back and look at my unit circle and see in quadrant 4, when we have that negative angle, we're at 11 pi over 6. Or sorry, the negative square root of 3 over 3. That's this one right here. So 11 pi over 6 is our tangent theta. That's why I write it as tangent theta equals y over x, rather than theta equals arctangent, because again, that would be a negative angle. In quadrant 4, a negative angle would or a negative tangent would produce a negative angle. It wouldn't give me this 11 pi over 6. It would give me a negative number. All right, now when you're doing this in your homework, the square root of 13, they would probably want to keep that, but this right here, they would probably have you round it. So if it's not a special angle like 11 pi over 6 or 5 pi over 4 or 2 pi over 3 or any of the ones that are on a unit circle, they'll probably want those. But if it's not, like there is no 2/3 on the unit circle for tangent. Remember, the special values for tangent are square root of 3, square root of 3 over 3, 1 over the square root of 3, 1, 0, undefined. 2/3 is not one of them. So when it's a non-special angle or non-special value, then typically they'll have you round those things. All right, that'll end this video. In the next video, we'll look at polar equations and converting from rectangular or Cartesian to polar equations.